What's up, guys? This is Miss Pearl. I'm going to go over section 8.1 with you, which is about scale drawings. And if we look at our key concept here, this is kind of a very complicated way of saying it, but I think you guys kind of understand when you see a scale model, something, it is proportional to the actual size of it. And then you can use this, y equals kx, where k is your scale, or k is your constant of proportionality. So like this example they gave you here, it would be 2. So in this example, 3 inches is going to become, you'll multiply by 2, so it'll become 6 yards, okay? Or 4.5 inches, if you multiply by 2, will become 9 yards in the actual scale. So I did some problems for you guys. I'm going to go through them kind of quickly. So again, you have this document, so if you need to go back, you can. If you need to pause the video and kind of think about what I said, then you can do that too. All right, so number 4, what is the actual base length of the triangle depicted in the scale drawing? Here's the most important part. Do this every single time. I labeled my meters and my inches. Label them. That's going to help keep you straight. So we have 2 meters is equivalent to 1 inch. That is your constant of proportionality, or your scale factor if they ask for it. Okay, they're asking you how many meters is it, your base, that's your variable, and they tell you that it's 2.5 inches. I know 2.5 belongs to my denominator because that's where I labeled inches. And again, we're going to cross multiply 2.5 times 2 divided by 1, and we get 5 meters. Number 5, what is the area of the actual square window in the scale drawing? So again, label it. We have meters and inches. So 2 meters is 1 inch. We don't know how many meters the actual length is, and then we know it's 0.75 inches. Cross multiply 0.75 times 2 divided by 1. You get 1.5 meters as your base. Now to find the area, length times width. Both are length. Oh, I wrote base times height. It should be length times width. Sorry, guys. But both are base. It's basically the same thing. Both our length and width, or our base and our height, are 1.5. Okay, multiply those two together, 2.25. Number 6 was a little bit tricky. A distance of 30 miles on a map is represented by a 2-inch line. If the map is enlarged to 3 times its size, what will the scale of the enlarged map be? This is a little bit tricky, though. So we have 30 miles is 2 inches. They're increasing the map by 3 times. So now they're saying, okay, 30 miles is 6 inches. Then all we're doing is reducing it. So we're going to divide top and bottom by 6. So 5 meters is 1 inch. And they like smaller to bigger. So we have 1 inch equals 5 miles. Again, if I'm going too fast for you, just pause the video and go back. I know you guys don't like to watch long videos, so I'm trying to shorten it up a little bit. Number 7, on a map, 1 inch equals 5 miles. 2 cities are 8 inches apart on the map. What is the actual distance between the cities? So again, I am going to label it. I'm looking at this number 8 here, and I'm saying, oh, okay, they're saying 8 inches, so I know 8 is the inches. That's how I knew to label my denominator inches. That means my numerator is the meters. Okay. Same thing with number 8. 1 inch is 3 feet. They're asking you about 5 inches. So I put 5 in my denominator. All right, and you might ask yourself, why am I always putting, if it was up to me, the way I would think of it is I would actually do it upside down and do 1 inch over 7.2 miles. But the reason I do it like this is if they ask you for your scale factor, it's going to be 7.2 divided by 1, which is just 7.2. All right, again, your scale factor for number 9 would be 7.2. Again, if you label it, you should be good to go. 1.5 times 7.2 divided by 1. Number 10, this is a tricky one. Tricky. So I'm actually going to, I put it on separate paper, so I'm actually going to scroll down for a second. If you're able to, I would try to get a screenshot or look in your book. This is in your book, number 10. Look at that while I go over it on the separate paper. The number 10 was tricky, but there are a few questions similar to this. The original blueprint for the Marino's living room has a scale of 2 inches equals 5 feet. So if you look here, that's what I did for this part and this part. 2 inches is 5 feet, and this part I found the length, this part I found the width. Let's keep going with the question. The family wants to use a new blueprint that shows the length of the living room to be 15 inches. If the width of the living room on the original blueprint is 6 inches and the length is 9.6 inches, what are the scale and the width of the new blueprint? This one's tricky. So I have my original blueprint, which I already said is 2 inches is 5 feet. And now in the question, they're telling me the original blueprint, the width is 6 inches and the length is 9.6 inches. So that's why I said my original blueprint, okay, my length is 9.6 inches. So now what is my actual length in feet for this, or the living room, right? Yeah. All right, so remember, the way to solve this, 9.6 times 5 divided by 2, and we get 24. Now we're going to do the same thing. In the original blueprint, okay, again, this is the scale for the original blueprint, and then they told us the original blueprint's width is 6 feet. So that's where this number came from. So again, 6 times 5 divided by 2 is 15 feet. Now we're going to find the scale factor. So K actually stands for scale factor. This 24 came from my length of 24. Now be careful. This 15 comes from the question, okay, where it says the family wants to use a new blueprint that shows the length of the living room to be 15 inches. So this 15 is 15 inches. If you do 24 divided by 15, you get 1.6. Okay, so that means that 1 inch equals 1.6 feet. Now we can answer the question. So 1.6 feet is 1 inch, and then the question is asking, what is the width? And we know, and this 15 is feet. Okay, so this is our actual length, and then we want to know our scale length. So again, the way we solve this is 15 times 1 divided by 1.6, and our new width for the new blueprint is going to be 9.375, or 9 and 375 thousandths inches on the new blueprint. All right, let's go over number 11. The scale for a drawing of the tennis court is 1 centimeter equals 2 meters. What is the area of the actual length? Now, it's kind of hard to see. I did label it in here, meters and centimeters. Okay, so if you look, both of these are very similar. We have 2 meters over 1 meter. I want to know the actual length, and the scaled length in inches is 10. So I got 20 meters for my length, and then the width, same thing, my original scale, 1 centimeter is 2 meters, and the width is 5.5 centimeters. So what's my actual width? Again, we labeled it. If you're not sure if your 5.5 goes in your numerator or your denominator, it's your denominator because that's where you labeled your centimeters to be. Now, area, length times width, 20 times 11, 220 meters squared. Number 12, last one. The scale for the drawing of a rectangular playing field is 2 inches equals 5 feet. Write an equation you can use to find the dimensions of the actual field, where x is a dimension of the scale drawing in inches. So if you look down here, I labeled it. We have 5 feet is 2 inches. And I said, oh, x is inches, so it belongs to my denominator. And y is the corresponding dimension of the actual field. That's feet. Now, honestly, you guys can take a shortcut. 5 over 2, that's your scale. Okay, that's your scale factor. But if you wanted to cross multiply, you have 2y 2 times y equals 5x. This is the long way to do it. We multiplied both sides by 2. This canceled, so we're left with y equals 5 over 2x. But again, you can take the shortcut. If they wanted a decimal, you could have done 5 divided by 2 and gotten 2.5. Again, it's part B, very similar to number 11. I found the length and the width, the actual length and width, and then multiplied. All right, if you have any questions, please make sure you ask me. I know I went through this kind of quickly, and I'm going to do 2 examples from the practice and problem solving, and your assignment is the additional practice, which is actually a little bit easier. I tried to take it easy on you guys this section because I think this section is a little bit confusing.